So solving linear systems with more than two variables can be challenging, obviously. Using elimination is what we did last section. And basically with elimination, you find one variable and then you back it into it. And so the Gaussian method of elimination basically does that, but you use matrices. So you basically zero out everything except for one variable. And then when you find that one variable, you back it into the others. Okay, which is the same concept. Gauss-Jordan elimination takes it a step further, and it just gets the identity matrix, all right, for everything. And then once you have the identity matrix, then you have all of your answers, actually. So we're going to be talking about the first thing is just setting it up as what's called an augmented matrix. And then we're going to talk about then how do we fix this to be the easiest way to get our answers, all right? So the first thing, a systems of equations, we know what this looks like. You can write it as an augmented matrix. You'll notice that it used the coefficients on that left side and it used the answers on the right. Simple enough. Rewriting a system to an augmented matrix. There we go. All right. And so when you're doing a Gaussian method, there are a couple things you can do. You can switch any two rows. So once you put it in an augmented matrix, you can switch the rows around. Why? Well, I just had a system of equations, so writing them in a different order doesn't actually change the equations at all, right? I can multiply or divide an entire row by a number. Again, I have an equation. As long as I multiply every piece of the equation by something or divide every piece of the equation by something, I haven't changed the equation, all right? Add a multiple of one row to the other. So I can multiply one row by something and add it to the other and change that second row. Well, that's basically what we do in elimination. So again, not a big concept here. But all of a sudden, you're not going to see your variables, okay? So a couple things. When you put in an augmented matrix, they have to be in standard form, meaning alphabetical order, X, Y, and Z, X, Y, and Z, or else you have an X over a Y, and that is going to cause a huge problem. So you want to make sure they're in order before you put it into an augmented matrix, and then you can do any of these processes to get what you want to get. All right, so let's look at this first one. Illustrate this to get an equivalent REF. And they actually talk about the Gaussian elimination gives you an augmented matrix right here. And it says a row echelon form. REF is just the short notation for row echelon form. It actually basically that first screen where it broke it down into what looked like the triangle and you had the Z by itself, that's what that means. And so we're going to get that zero out everything under the bottom side of the triangle, and we're going to get ones in the top side of the triangle to try to get that last variable solved for. So that's what that means when you see that REF, all right? And so when I'm looking at this particular one, the first thing I'm going to try to do when I get this Gaussian method here is I am going to try to get this guy to look something like this. So I'm going to try to get any number here, it doesn't matter what's there, and a 1 here, and any numbers here and a 1 here, okay? That's what I'm going to try to do. I'm going to try to zero out everything under the triangle and get ones here, all right? And so the first thing I'm going to look at when I do this is, can I just flip-flop them to get ones where I need them to be, all right? And so to get maybe this one, it's in the first position, but I really need that one to be on the top row. Well, I can flip-flop any two rows. And so that's what I'm going to do at first. I'm going to rewrite this and just flip-flop these rows. Because really, I'm just talking about systems of equations. It doesn't matter which order I write them in. All right, so I'm going to rewrite this. And it lists out to the side kind of what you're doing. We're going to exchange row 1 and row 3. All right? And so that's what we're going to do. We're going to rewrite it like this. And I always actually write the line here because it represents my answers so I can keep track of what's going on. I'm going to leave this row alone. And I'm going to replace this third row with that first row. All right, so that gets my 1 in the first position that I want it in, all right? Gets my 1 in the first position, all right? Questions on that one? Now here's the thing. Anytime you have a 1, it's really easy to zero out the ones below it, right? Think about if I have an x by itself and then, in this case, a 4x or a negative 2x. It's pretty easy to use that x to zero out. In fact, if I were eliminating, that's what I would do. So now I'm going to use this 1 to eliminate the 4 and to eliminate the negative 2, all right? And that's going to help me get those zeros where I need it to be. And that's actually the method that I always use. I find my 1 first, and then I eliminate everything underneath it, because then it's zeroed, and then if I add it to anything, it's already a 0, all right? And so how would I do that? Well, if I were eliminating, I would multiply the first row by negative 4 and add it to the second row, and that would eliminate my positive 4 underneath it, right? So what I typically do is I do like a temporary multiplication. So when I do this, I'm say, okay, I'm going to take that row. He's not actually going to change, okay? And I am going to temporarily multiply it by negative 4. So I write little small numbers above it. This just helps my brain, because basically what I'm going to do is I'm going to multiply that negative 4 in, and then I'm going to divide it back out, right? And so instead of writing it all those many times, I'm going to do a temporary number above it, all right? So multiply this by negative 4, multiply this by negative 4, multiply this by negative 4, and multiply this by negative 4. So, all right, so positive 68. All right? Does that make sense? And then I'm going to add it to my second row. So I'm going to say a negative 4 plus a 4. That's going to give me that 0. And then I'm going to say a 12 and a negative 3. That's going to give me my 9. No. Negative 11. Sorry, I added to the wrong row. I'm already switching it up. All right. So I'm going to say a 12 and a negative 1. And then a negative 24 and a positive 2. Right? And then I'm going to say a positive 68 and a negative 13. All right, so far so good. Now I'm actually going to do it all in one step, because I don't like to rewrite the matrix 14 times. I'm being honest. I'm not going to write it 14 times. So I'm actually going to do yet another step here all at one time. It doesn't matter, because I just multiplied by the 4 and divided by the 4, okay? Now I'm going to get rid of the negative 2. So what do I need to multiply this guy by now temporarily? Positive 2. So I'm going to multiply those all by positive 2. So these guys are gone now. I've already used them. 1 times positive 2, negative 3 times positive 2, 6 times positive 2, and negative 17 by positive 2. All right? And then I'm going to add those to the third row. Everybody see what I'm doing? So now I'm going to say positive 2 and negative 2, negative 6 and positive 5, positive 12 and positive 2, and negative 34 and positive 23, right? So what am I going to get there? Negative 9? Negative 11. There we go. Help me out. Here's the thing. Personally, there's a couple things you could do here. You could divide everything by 11 and get rid of that 1. I'm going to do that because everything in that row is divisible by 11, all right? So you see how everything in this row is divisible by 11? Mm-hmm. I need him to be a 1. That's an easy thing. However, if everything in this row was not divisible by 11, what do you think I would do here? I'd switch these two things and divide by negative 1 and get that 1 where I needed it to be. Do you see that? So I need a 1 right here. Remember, I'm trying to do a 1 on the diagonal. In this case, I have a beautiful 11, 22, and 55. They are all divisible by this guy. I can divide the entire thing by 11. If it were not that simple and I was going to get horrific fractions, I would switch these two rows because I have a 1 right here and I would just have to divide by negative 1. Does everybody see that there's two things I could do here? The 11 is simple, so I'll just divide by 11. But if it weren't that simple, I wouldn't do that. So I'm just going to go ahead and divide this second row by 11. So I have 1, negative 3, 6, and negative 17, which is not going to be affected. I have a 0, a negative 1, a 14, and a negative 11 that's not going to be effective. Then I'm going to divide everything by this second row by 11. So 0 divided by 11, 11 divided by 11, negative 22 divided by 11, 55 divided by 11. All right. So that's pretty. I'm good with that, okay? I need to zero out what's underneath that 1. Well, they were very nice to me. I have a positive 1 and a negative 1. I can just add those 2 rows together. So my next little set here, this guy is done. We don't have to worry about him right now. Okay. This guy's done. We don't have to worry about him. But now I'm going to add these 2 rows to get rid of that negative 1. So 0 and 0 are 0, 1 and negative 1, 0, negative 2 and 14, and then 5 and negative 11. All right. So far, so good. I need the final 1. It's not going to be as pretty as I like, but give me that final 1. I can divide everything by 12, right? Everybody see that? So I have this guy is not affected. This guy is not affected. And this guy is going to be that. What have I done? I have solved for z. Okay? I've solved for z. Z equals, if this was an xyz, z equals negative 1/2. All right? I have 1 times z equals negative 1/2. If I were to rewrite this as an augmented, as from augmented to a standard, right? If I were to go the other direction, and this is my x column, this is my y, and this is my z, I've solved for z. Okay? This is Gaussian method. Once I have z, I can back insert it. Okay? So that means I can insert it into what this guy would be. All right? This guy would be 1y minus 2z equals 5, right? So if I plug in a negative 1/2, I'm going to get a positive 1, subtract, right? Y is going to equal what? Negative 2 times negative 1/2 is 1. Subtract 1, y will equal 4, right? And then I can plug those into this guy. This is my x, this is my y, this is my z. That's the Gaussian method, just to get half of your triangle zeroed out and solve for that final variable and then back plug it in, all right? That's the Gaussian method. Questions on the Gaussian method? So they gave it to you in XYZ up at the top, okay? Top right, we see that we have our actual systems of equations. So if I were to write this out in an augmented matrix, first of all, they're in order for the first 2, but the last one is not, okay? So before I do anything, I'm going to rewrite that last guy. So this one is x, y, z in number. This one is x, y. I don't have a z, so that's basically 0 in number. Here I have a problem. I can't leave him like this. So before I do anything, I'm going to rewrite this little guy here, if it'll let me. All right, I'm going to move my x over. That would be a negative x, a positive 2y, move the 0 over, a negative 4z, move the 10 over, negative 10. So I'm going to rewrite him so that he's in the correct order. That's all I did. And then I'm going to do my augmented matrix. So I have a 3x, a 4y, a 5z, and a negative 13. I have a 1x, a negative 2y, a 0z, and a 14. Then I have a negative 1x, a positive 2y, a negative 4z, and a negative 10. Okay?
Can I do the positives of the last one?
So I can immediately see that if I add these 2 rows, my x and my z column, my x and my y column will cancel. Everybody see that? Mm-hmm. So I'm just going to do that before I jump to shifting it around and all that good stuff. I'm going to leave this guy alone.
So you don't have to get the whole thing to the 1, 0, 0.
Not if it does this. Yeah.
Just have to get this.
Yeah. So I have to leave these here. Okay, I have to leave those here. But I'm going to immediately find my z. And then I can shift around if I need to, right? Why would I need to? Well, because the other 2 only have an xy or an xy and z. So I am going to have to solve for another variable, right?
So you can't replace it with the second one as you just have all zeros.
Right. So if I do 1 and negative 1, that's 0. 2 and negative 2, that's 0. 0 and negative 4, that's negative 4. And then I have a negative, I'm positive 4, sorry. Okay. So I can do that first. That makes my life easier right here. Okay. And so I have this guy right here. I have this one. And then I'm going to divide by what? -4, right? So I get 1 equals -1. All right. So I have that 0 right there and that 1. That's what I need. Everybody see that? All right, so now I really need to eliminate at least one variable from the other. Why? Well, I can't, let's say I wanted to backfill it. It doesn't help me because this is a 0 and I still have an x and a y. Everybody see that? All right, so I need to do something to get rid of a variable. So now I can manipulate the other two and just work with those. I'm going to leave the third guy alone completely because I already know what z is. But I need to manipulate the other two where z helps me because right now z doesn't help me solve the other two. Okay? So in this case, now I'm going to flip-flop those two rows. Right? So now I'm going to flip-flop these two rows so that my 1 is where it needs to be because dividing by 3 would be horrific. Right? So we're going to flip-flop those two rows, leaving my third row alone. I have 1, -2, 5, -13. No. See, look how easy this is. I'm just like doing it too. There we go. 1, -2, 0, and 14, and then 3, 4, 5, and -13. I just flip-flop those two rows, 0, 0, 1, and -1. All right. Now I'm going to do some elimination. Okay. Now I'm going to eliminate that 3 under my 1. It's the easiest thing to eliminate. Okay. So I'm going to temporarily multiply this top row by a -3, -3, +6, that's a 0, and then -42. Okay. And I'm going to add it to my second row. Leave my first row alone. Leave my third row alone, rather. And then just simplify this row. +3 and -3, that guy zeroes out. +6 and 4, 0 and 5, -42 and -13. All right. Before I backfill, what do you think I'm going to do with that second row? Divide everything by 5, right? Yeah. Divide by 5 and then I can plug my z in, can't I? Right? So I can say 1, -2, 0, and 14. Divide by 5.
Wait, weren't you multiplying by a -3? Like the top row by a -3, so that when you add it down, it goes on?
Right. So 1 times -3 is -3. -3 and +3 are 0. -2 times -3 is +6. +6 and 4 are 10. 0 times -3 is 0. 0 and 5 are 5. 14 times -3 is -42. -42 and -13 are -55. All right, now my z helps me. Does everybody see why my z did not help me before? Right at this point where I got my z didn't help me. First of all, if I plug a z in here, it zeroes out. I still have an x and a y. Doesn't help me. If I plug it in here, yeah, I have my z, but I still have 2 variables. Also doesn't help me. At this point, it helps me, right? I flip-flop those, zeroed out my x column. I have a y and a z column. Now I can plug it back in. Okay, so now I can say, well, this is 2y plus 1z equals -11. And I can plug that -1 in, right? So -1, then add it to the other side and divide by 2. I'm going to get my z equals -1. I'm going to get my y equals -5. And then I can go up here and plug those in. This is my x. This is my y. Z zeroes out. So I just need that -5 is really what I needed there. -2 times -5 is +10 minus a cross. So 14 minus 10 is 4. So my x is going to equal +4. So once it helps me, I can stop, right? I don't have to keep fixing it once it helps me. I can stop and back plug it in. Gauss-Jordan, we're on page 355. Gauss-Jordan kind of combines the Gaussian with another process. So Gaussian method says just solve for z and backfill it, okay? The Gauss-Jordan says, well, if you're already there, why don't you just get the identity matrix? And when you do, you have your answers for x, y, and z, okay? So if you get all of your zeros except your diagonal, you have 1x equals this, 1y equals that, 1z equals that. You have your answers. While you already have your ones, zero everything out except that one, and then you have your answers and you're done, okay? So Gauss-Jordan seems to take it a step further, but it's not really. You're just kind of using those ones to manipulate it out and find your x, y, and z without having to backfill. That's what this method does, okay? So, yeah. So, again, you do want to make sure you're in x, y, z. Check those. Make sure you're in standard form. If you're not in standard form, fix it before you start. And then we're just going to write it out. So I have a 2, a 1, a -1, a -7, a -2, +3, -4, -18, -1, -2, +2, +11. All right. So I am trying to make the left side of this look like that. That is my goal. So I'm actually going to flip some rows here, right? Because that's going to make my life easier if I flip some rows. And so I'll flip some rows and then see how that helps me. And so I'm obviously going to put my third row at the top, right? So we can flip-flop row 1 and row 3. That's fine. And at the same time, I need that to be a positive one, so I'm actually going to negate my row as well, okay? I am going to say we're going to flip-flop row 1 and negate row 3 while we do it, okay? So I'm just going to flip-flop those rows and negate it at the same time. So I will rewrite that. I'm going to, a -1 will become a +1, -2 will become a +2, negate that 2, negate that 11. I didn't really touch the second row, so we're going to write that exactly the way that we had it. And then my 3 is going to come down, so this is going to be a 2, a 1, a -1, and a -7. That's all I've done so far. All right? So far, so good? We good? Okay. All right, so at this point, there's a couple things you can do. You can add, really what I'm trying to do here, once I get my 1, I'm trying to zero everything else underneath it, is what I'm trying to do, okay? So I can say, well, I could add row 3 to row 2, and that would zero him out, right? And then I can add, once I do that, then I can do another step. But if I add those 2, I can, or I can multiply the top one by 2 and add it. Like whatever I want to do, I can do it. I'm just trying to zero those out, okay? And so I think they added row 1 and row 2. I don't know why they did that. I wouldn't do that. But I would probably add either a 2 times the top and add it to the second one, and then a -2 and add it to the bottom one, whatever your brain thinks to do here. We're trying to zero out everything underneath our 1. All right. It's not going to help me to flip-flop these rows, because when I add anything to this to zero it out, even though this 1 is in the right place for row 2, it's not going to be a 1 anymore when I do this process, right? So I would probably just multiply by the 2 and add so that I'm not confusing myself. So I'm going to just say, well, I'll multiply row 1 by 2 and add it to row 2. And then I'm going to multiply row 1 by -2 and add it to row 3. I'm going to do all of that in one step. All right. So when I do this, my first row doesn't change, but the rest of the rows are going to change. So if I multiply this by 2, that'll be 2, 4, -4, -22, right? And then I'm going to add it to this row here. So I say +2 and -2, that will zero that out. +4 and +3. -4 and -4. And then -22 and -18. All right. So far, so good. And then I'm going to do the same thing here, but I'm going to change those numbers to the opposite because now I'm multiplying by a -2. So that's going to be a -2, a -4, a +4, and a +22 that I'm going to add to row 3. So I'm going to say -2 and +2 once again give me 0. -4 and +1 give me a -3. +4 and -1 give me a +3. And then +22 and -7 give me a +15. Nope, we don't want it in highlighter. There we go. All right. So far, so good. Now, here's where I may want to flip 2 rows. Why do you think I may want to do that? Because I'm going to get a pretty easy one here or an easy one there, one or the other. But I feel like this is an easier place to get rid of stuff. That's just me than the other one. That's my personal opinion there, okay? And then I can zero out above and below it. So I would probably flip these 2 and divide everything by -3 here to get my 1 where I need it to be. So I'm going to do that all at once. So I am going to switch row. I'm going to switch row 2 with -1/3 of row 3, right? I'm just divide by -3. Everybody see that? So my first row I leave alone. My second row is now going to be this divided by -3. So -3 divided by -3 is 1. +3 divided by -3 is -1. 15 divided by -3 is -5. And then leave the sky alone for right now. So far, so good? Now, once I have that 1, I'm going to use him to eliminate the zeros above and below him. Okay? Just like I used this guy to eliminate these zeros, I'm going to use him to eliminate these. Does everybody see that? Okay? So as soon as I get a 1 in this method, I'm eliminating everything above and below it. Everything else will be a 0 above and below it. Okay? So to do that, I need to multiply. To get rid of this guy, I need to multiply row 2 by a -2 and add it to row 1. I need to multiply this guy by a -7 and add it to row 3. I'm getting rid of my numbers above and below it, okay? All right, so when I do that, I end up with, so I'm going to go ahead and write these out, a -2, a +2, and a +10, right? That's what happens when I multiply by -2. So my top row, the 0, that's why I have that 0 there, because once I zero everything out, it will never get touched by anything underneath it. That's why I zero it out. If I don't zero out, it's going to change it if I try to add 2 rows again, okay? So -2, the 1 doesn't change. -2 and +2 give me a 0. +2, this is nice, and -2 also give me a 0. And then +10 and -11 give me a -1. All right, so far so good. The middle row doesn't change on this activity because I'm not actually doing anything to this guy. So we're going to leave him alone. Oh my gosh, this one. All right, and then this one, I'm going to -7. So this is a 0, -7 and +7, +7 and -8, +35 and -40. I already have my 1. I can multiply this guy by -1, right? And then add it to the other one. So my last step here is just this guy is solved for. This guy is going to be solved for once I do that. And then add this row to that one. So 0, 0, 0, and 1, a +1 and -1, +5, and a -5. Looks like that.